growth and decay. Our essential question is, how do you decide which formula to use to solve an exponential problem? You see under our questions, so we have 3 new vocabulary words. So we have 3 different formulas that we're going to be working on in this section. Please make sure that you write down the formulas and what all of the variables stand for in each formula in your notes. First, the exponential growth formula. Y equals A times the quantity 1 plus R to the power of t, where A represents the initial amount, R represents the rate of change in decimal form, and t represents time, y represents the final amount. Exponential growth problems involve something that is growing, and it could be growing rapidly. Exponential decay formula, you may notice, looks exactly like the exponential growth formula, except for the plus in red has been changed to a minus, because decay means that something is decreasing or going down in value, so the rate is going to be subtracted instead of added onto the 1. The rest of the formula and what the variables represent are the same. The third and most complicated formula is the compound interest formula. This is a formula that could be used, compound interest is used when you purchase something like, say, a house, or you purchase a car, or you take out a loan from the bank. Interest is often compounded, which means that it may be calculated more than once a year. So this formula is much more complicated. This formula is also used if you invest money. You may be investing money where interest is compounded. So it doesn't just mean that you're paying money back to a bank, it could mean that you're making money instead. So A represents the current amount, P represents the principal or the initial amount. So that would be the amount that you borrowed or the amount that you invested. Then in parentheses we've got 1 plus R divided by N. The ratio of R over N, where R is the annual interest rate in decimal form, and N is the number of times the interest is compounded each year. So if it was monthly, N would be 12. If it was quarterly, N would be 4. If it was semi-annually, N would be 2, for example. So the value for N changes. You just have to be careful when you're reading the problem to figure it out. And then the exponent outside of parentheses is now N times T, where T is the time in years. Our first example is about tuition. A college's tuition has risen 5% each year since 2000. If the tuition in 2000 was $10,850, write an equation for the amount of the tuition T years after 2000. So the first part, we are going to write an equation. And we should be using the formula, if we look back, because it's increasing, we should be using the exponential growth formula. So y equals A, and then it times the quantity 1 plus R to the t power. That's our formula that we're going to use to answer the question in red. Now the starting amount for the tuition is $10,850. The interest rate in decimal form, 5% as a decimal is 0.05. Remember that a percent is out of 100, so it's 2 decimal places that you have to move your decimal point to put it in decimal form from a percent. So 1 plus 0.05 to the t power. So our general formula that we could use for any amount of years would look like this. I simply added 1 plus 0.05 to get 1.05. Now to answer the question in blue, predict the cost of tuition for this college in the year 2015. Well, the year 2015 would be how many years after 2000? It would be 15 years. So I'm simply going to use the exponent 15, and then I'm going to plug this in my calculator, and Remember that on our calculators that we use in class, the upside down V or caret key is our power key, where we can put in any exponent. So 10,850 times 1.05 to the power of 15 gives me a value of approximately $22,556. On your homework problems today, you will notice that sometimes they give you specifics to rounding your numbers, so just be careful and make sure you're reading so that your answer is written correctly. Example number 2. The population of Campbell County, Kentucky has been decreasing at an average rate of about 0.3% per year. In 2000, its population was 88,647. Write an equation to represent the population since 2000. Well, if we go back to our formulas, because this population is decreasing, we are going to need the exponential decay formula. So, our decay formula, to answer the question in red, y equals a times 1 minus r to the t power. Our starting population is 88,647. Our decimal, when you look at a percent of 0.3%, I understand that there's a decimal point in that percent. That's not decimal form, though, for that number. Decimal form, we still have to move our decimal point back 2 places. So in decimal form, it would be 0.003. 0.003. So 1 minus 0.003 to the power of t. And if I subtract 1 minus 0.003, I will get my general formula that we could use for any amount of time, and that would be 0.997 to the t power. Next, we're going to answer the question that is in black. If the trend continues, predict the population in 2010. Well, the year 2010 would be 10 years after 2000, so that means that my exponent is going to be 10. So 88,647 times 0.997 to the 10th power. Gives me a population of approximately 86,023 people. Please remember that word problems require word labels. So on the previous problem, our answer has a $sign as a label, and on this problem, I've labeled it with people. Our third example. Maria's parents invested $14,000 at 6% per year, compounded monthly. How much money will there be in the account after 10 years? Well, if we go back to the formulas again, the formula that we need for this one is the compound interest formula. So A equals P times 1 plus R divided by N over NT. A equals P times 1 plus R divided by N to the power of N times T. Okay, so to answer our question, how much money will be in the account after 10 years? It started out at 14,000, so that is our starting principal. 1 plus our interest rate, 6% is 0.06, divided by the number of times it's compounded, which is monthly. Months would be 12. So then 12 also gets filled in for our exponent, but it has to be multiplied by the number of years, which is 10. So our exponent is going to be 120. So 14,000 times 1 plus something, 120. 120th power. I'm going to divide 0.06 by 12, and I get 0.005. Please remember that whenever you round something, you're estimating. That is not rounded. That is not rounded. So far I have an exact answer. And if you're rounding early in a problem, you probably are going to end up a little bit off versus rounding at the end. So it's always best to try to round later. So if I calculate this, 14,000 times 1.005 to the power of 120, the amount in the account, and this is going to be an approximate value because I am rounding this, so approximately $25,471. One more example with that compound interest formula. A equals P times 1 plus R over N, the NT power. Okay. When Jing Mei was born, her grandparents invested $1,000. So that is my principal. And it's in a fixed rate savings account at a rate of 2%. So my rate is 0.02, compounded semi-annually. Semi-annually means twice a year. So N is 2, and they're asking how much is going to be in her account when she turns 18. So T is 18. So 1,000 times 1 plus 0.02 divided by 2 is 0.01, and my exponent is 36. So in my calculator, I'm going to enter this and approximate it. So 1,000 times 1.01 to the power of 36, $1,430 is our estimate. Please remember that if you do not have a calculator at home, you could certainly find one online. Calculators.com or another website would have a calculator that you could use. You should now be able to write your summary and work on your homework assignment. The first 12 problems are the new formulas, and then 28 to 33 is a review of the quadratic formula where you could use factoring or the quadratic formula, solving quadratics. So these are the new formulas, 1 through 12. Make sure that you write out your work so that we can tell if you make a mistake, we can find the error.